They are pulling the plug on our storm tracking lifeline right when we need it most. That was the outraged reaction echoing through meteorological circles the moment news broke that, with almost no warning, critical satellite data from the Defense Meteorological Satellite Program would be withdrawn from the National Oceanic and Atmospheric Administration. Some meteorologists describe this support's abrupt removal as the equivalent of snatching away the blueprint from engineers right in the middle of building a complex structure. This is how the chaos of a growing hurricane season begins: under-resourced, under-informed, and potentially under serious threat. What on earth is happening in the realm of weather forecasting, and why are so many scientists worried that losing these naval satellite feeds could jeopardize lives during the year's most dangerous storms? In the next few minutes, we will uncover the political tensions behind these abrupt changes, examine the cutting-edge instruments that granted meteorologists a virtual X-ray of storms and why they may vanish, and explore the possibility of a future where coastal cities would have minimal warning about fast-forming hurricanes. Get ready, because the unsettling question of how we will predict rapid intensification is about to take center stage. In this video, we will go in depth on the tense standoff among federal agencies, the hidden vulnerabilities of the meteorological infrastructure, and the intriguing interplay of technology, funding, and sheer human resilience, factors that all collide in the swirl of tropical cyclones. If you find the unfolding story of administrative tangles and high-stakes hurricane forecasting compelling so far, please hit the like button. It might seem like a small step, but it helps bring this discussion to more people who care about environmental preparedness and public safety. Let's trace the timeline of this looming crisis, starting with the abrupt Navy announcement. On a seemingly routine Wednesday in late June, the Fleet Numerical Meteorology and Oceanography Center declared that, in just a few days, it would be forced to shut down the data processing system for the Defense Meteorological Satellite Program. This program, often shortened to DMSP, originated in the 1960s and has served as an invaluable resource for the military and civilian weather communities for over 50 years. Put simply, it's a constellation of orbiting sentinels that keep watch over Earth's weather patterns using a suite of advanced instruments. One of the crown jewels of DMSP data is the microwave imagery captured by the Special Sensor Microwave Image Sounder. This device allows meteorologists a precious view inside storms. Even with thick clouds, swirling rain bands, and powerful winds muddling visibility, the data can produce something akin to a three-dimensional map of a cyclone's core. In normal circumstances, forecasters consult this imagery almost like surgeons rely on an MRI. They can see the structural integrity of an eye wall or gauge subtle aspects of the internal temperature shifts that might signal quick strengthening. The timing of this data shutdown could not be more precarious. Hurricane season runs from the 1st of June through the end of November, with peak months in August, September, and October bringing some of the most significant tempests. Officials from both the National Oceanic and Atmospheric Administration and the National Hurricane Center found themselves blindsided. Losing that valuable real-time data might degrade forecast accuracy, hamper predictions of storm intensification, and ultimately put millions of coastal residents at higher risk. Initially, the Navy's meteorological branch had planned to terminate the DMSP data feed on the 30th of June, citing severe and unexplained cybersecurity risks as the cause. But after urgent appeals from the National Aeronautics and Space Administration, among others, the Navy granted a short extension. That gave these scientists and government agencies a marginal extra window until the 31st of July to scramble for temporary solutions. Unfortunately, it appears there is no official plan to reinstate the data feed once the new Defense Department weather satellite commences operation in October. This gap is precisely what has meteorologists wringing their hands. We should also mention that the National Oceanic and Atmospheric Administration has insisted that its hurricane forecasts will not suffer too greatly. According to statements from agency representatives, NOAA's meteorological experts have multiple sources of data, everything from modern satellites, oceanic floats, and land-based radar systems to aircraft reconnaissance. Nonetheless, there is a crucial distinction. The DMSP instruments are especially adept at scanning the storm's innermost structures. Let's imagine a hurricane swirling in from the Atlantic Ocean to the Gulf of Mexico. It might look just like a crisp swirling disk on a typical satellite's cloud-top view. But inside that epic mass of moisture, many processes are unfolding. Rain bands can intensify around the center. The eye wall can shrink or expand. Concentric rings of towering thunderclouds can form and disintegrate in a matter of hours. Without the near real-time microwave imagery from the DMSP constellation, meteorologists crucially lose the ability to peer beneath those dense clouds and observe the actual architecture of the storm. Why is that so important? The National Hurricane Center, among others, has historically relied on data from DMSP to anticipate what forecasters call rapid intensification. This phenomenon becomes the stuff of nightmares for coastal communities since it describes when a storm's maximum sustained winds leap by at least 30 knots in a short, typically one-day time frame. Hurricane Milton, which ravaged the west coast of Florida in the second week of October 2024, was an infamous example. Within 24 hours, that storm mushroomed from a Category 1 to a Category 5. If there is no advanced warning, local emergency managers might have insufficient time to coordinate evacuations or readiness measures, leaving populations exposed to life-threatening conditions. You might assume that a modern, high-tech agency like NOAA would have backup instruments or straightforward alternatives. But in an era marked by budget cuts and staff reductions, NOAA's technological arsenal has already been stretched. The sudden disappearance of critical data from DMSP is not the only blow to the agency's forecasting capabilities. Another portion of NOAA's data-gathering efforts relied on sail drones, specialized drone ships that gather real-time meteorological information right from the ocean's surface during hurricane conditions. NOAA used these floating platforms for 4 consecutive years, venturing them into the hearts of storms to capture rare in situ measurements. However, in yet another surprising twist, the California-based company behind the sail drones was unable to participate in the new NOAA contract. That means these fearless storm-chasing vessels will not be part of NOAA's data puzzle this year, removing yet another vantage point for scientists to catch early signs that a tropical system could suddenly intensify. It is a sobering turn of events that further clouds the reliability of forecasts in what could be an active hurricane season. If you are as astonished by this unfolding story as many meteorologists are, please subscribe to stay in the loop on future developments. Every bit of engagement helps ensure essential discussions, like the one about safeguarding communities from hurricanes, reach people who need this information. Let us reflect for a moment on the bigger picture. Over the last few decades, the National Oceanic and Atmospheric Administration's capacity for monitoring storms expanded in leaps and bounds. From the 2005 hurricane season, which famously hosted Katrina, Rita, and Wilma, to the present day, NOAA and the National Hurricane Center refined countless prediction models, set up better computer simulations, and used brand new satellites in synergy with plane-based radars and oceanic sensors. The introduction of the DMSP data feed made that forecast tapestry even richer. However, challenges sprang up almost as quickly as the advanced technology. Under the administration of President Donald Trump, for instance, NOAA faced a flurry of staff cuts, budget restrictions, and constraints on travel and training. Alongside these internal pressures, the entire world of weather forecasting has become more urgent. Climate change factors are believed to be intensifying some storms, or at least influencing rainfall and storm surge patterns. In short, the forecasting mission is growing more complex right as NOAA's arsenal of tools is reduced. Through it all, meteorologists insist that the absolute priority is saving lives by giving people in harm's way as much lead time as possible. The DMSP satellites specialized in offering glimpses of those subtle swirling events in the eye and eye wall. These glimpses might otherwise remain hidden beneath layers of cloud. What would it mean to proceed without that vantage? A narrower window to detect hidden signs of quickening intensity, a decreased ability to confirm how moisture is wrapping around the center, and an overall reduced confidence in the storm surge and wind strength calculation. In the best-case scenario, NOAA might still glean enough data from alternative sources to keep forecasts accurate for typical storms. The trouble arises with borderline systems that might, with the slightest atmospheric nudge, explode into major hurricanes. Without DMSP's microwave sensors or the sail drone fleet, meteorologists could find themselves in the dark about these critical transformations until late in the game. Many meteorologists stress that these predicted forecast downgrades might be subtle at first, perhaps a few miles per hour difference in wind speed predictions or a slight miscalculation of the storm's future track. But the margin for error can become catastrophic if a storm quickly leaps from moderate to monstrous. In particular, local emergency planners rely on accurate readings for the storm's position, future trajectory, and intensity timeline to inform coastal evacuations, mobilization of medical services, and placement of rescue teams. A minor forecasting slip of 12 hours might be the deciding factor between an orderly evacuation and thousands of people stranded on highways. Concerns have also spilled over into the scientific community at large. During the last half-century, an amazing synergy existed between the Department of Defense's capabilities and NOAA's civilian mission. Even though the DMSP satellites were originally designed to support the United States military, with weather intelligence for troop movements and tactical planning, local meteorologists, climate researchers, and hurricane specialists benefited immensely from that same data stream. Now, with the Defense Meteorological Satellite Program's era nearing its end and concerns about cybersecurity or technical obsolescence, analysts worry that the new military satellites might not share the data as freely. Behind the scenes, some meteorologists and climate experts see this shift as a microcosm of a broader issue: how unfunded or poorly coordinated transitions between agencies can cause disruptions in the continuity of vital data. Historically, the impetus for the DMSP changes included budget constraints and legal wrangling over launching new satellites. The Defense Department's attempt to modernize its orbital hardware was plagued by cost overruns and design challenges, leading to a prolonged lull between older satellites winding down and newer ones becoming fully operational. Meanwhile, the National Oceanic and Atmospheric Administration anxiously eyes the horizon. This particular hurricane season is projected to be especially active, with some scientists anticipating up to 10 named storms. Even if only a portion become major hurricanes, it is enough to threaten U.S. coastlines, the Caribbean islands, and beyond. During typical hurricane seasons, forecasters rely heavily on multiple data sources. But removing a significant chunk of those sources during a potential wave of storms feels to many experts like disabling the bridges leading to a fortress while an army is marching toward the gates. We can take a historical lens to highlight why forecasting matters so much. The raw power of storms has left countless marks on the timeline of the Western Hemisphere. Hurricanes like Andrew in the early 1990s, Katrina in 2005, Michael in 2018, and Ida in 2021 showed that short-notice changes in intensity can catch entire regions off guard, causing devastating harm. Data from previous storms tell us that hours lead to thousands of saved lives if warnings are heeded. And what about the climatic dimension? Some forecasters combine data from satellites like DMSP with field research to understand how warming ocean surfaces and shifting atmospheric currents can intensify a hurricane's growth. Through this lens, even a few degrees difference in sea temperature can be the difference between a storm that fizzles and one that grows into a monstrous, slow-moving, destructive force. Without this crucial microwave data peering beneath the clouds, it becomes harder to measure water vapor profiles inside the storm's main convection areas. The result? Another blind spot in the puzzle of forecasting. In response, NOAA leaders continue to reassure the public that advanced NOAA satellites, drone aircraft like the Global Hawk, and specialized telescopes on geostationary platforms can plug the gap, but it is not quite that simple. The strengths of high-orbit satellites revolve around scanning the tops of cloud layers, while DMSP's unique vantage point was near polar orbits capturing more detailed cross-sections. The synergy between these vantage points gave meteorologists a more complete story of what was unfolding inside the spinning chaos of a hurricane. Lose one piece, and the entire puzzle might be missing critical details. That is not to say we are heading into a scenario where next week's hurricane will be invisible to modern technology, but it does mean that smaller, faster evolving storms might slip under the radar until the last minute. For coastal infrastructure in places like Florida, Texas, or the Carolinas, that last minute might be too late to fully mobilize. One might wonder, can NASA, the National Oceanic and Atmospheric Administration, or the Department of Defense simply sign a new agreement at breakneck speed to restore data access? While that might be a logical solution on paper, the reality is more convoluted. The Department of Defense cites persistent cybersecurity concerns that it claims pose a substantial threat to the entire data pipeline. Unresolved technical issues, bureaucratic procedures, and ongoing organizational reorientations complicate this tug-of-war. The short version: there is no quick fix on the horizon, so the tension remains high. Meanwhile, other forecasters, such as those affiliated with private companies or academic institutions, are sounding an alarm. If federal agencies struggle to share data among themselves, where does that leave smaller research labs or local forecasters who don't have big budgets but desperately rely on government-provided satellite intelligence? Some have proposed forging new public-private partnerships to put smaller specialized instruments in orbit, but launching new satellites, even cube satellites, is neither simple nor cheap, especially for the sensitive microwave imaging technology. Thus, the near-future outlook feels precarious. Reflecting on the reaction from the meteorological community, it is telling how passionately some experts are speaking out. One researcher described the decision to shut down DMSP data as something that will kill people, making it clear that the stakes here are not just theoretical. Even if that statement sounds dramatic, the point underscores the life-or-death significance of advanced warning systems. In a domain where the difference between a well-prepared citizenry and a frantic scramble can be measured in terms of thousands of lives, strong words might well be justified. Some critics have directed their ire at broader patterns of funding. The question arises, are we witnessing the beginning of a silent crisis for American weather forecasting, or is this just a temporary glitch? Historically, the National Hurricane Center overcame many obstacles by leaning on decades of data archives and a robust model system refined by state-of-the-art computing. But if the pipeline of new real-time data sources dries up or becomes sporadic, that well-honed system could degrade. Tropical meteorology is largely about pattern recognition. The data from older storms, gleaned from satellites, research flights, surface sensors, and even specialized drone missions, help shape the algorithms that forecasters use to project future hurricane behavior. Take away a critical puzzle piece, and while the entire system does not collapse immediately, it might become less reliable over time. The upshot is that forecasts which used to carry a certain margin of error might now carry a bigger margin, leaving local governments with less confidence in planning efforts. Harkening back to the synergy NOAA once had with collaborative partners, one can only hope that a new wave of negotiations results in at least partial restoration of the feed or the accelerated deployment of advanced replacements. On the one hand, the Department of Defense is already preparing fresh satellites for launch with updated technology, but it is uncertain whether that payload includes the microwave imagers that NOAA depends on, and equally uncertain if data from them will flow freely across agencies. The storyline of sail drones also showcases how even innovative solutions can slip away when contract terms or finances are not aligned. That technology was specifically designed to brave the roughest seas in a hurricane's midst, capturing surface temperatures, wind speeds, barometric pressures, and other on-the-spot phenomena that standard instruments could only approximate from afar. Combining that vantage with overhead satellites was an ingenious leap in hurricane science. But for the current season, such synergy will not materialize. As coastal residents from Maine down to the Texas Gulf hold their collective breath during the unpredictable hurricane months, agencies like the Federal Emergency Management Agency must plan based on the most accurate data they can glean. This season's storms might be relatively mild, or we could face a succession of tempestuous landfalls. If a major system is headed for a heavily populated region and spins up in intensity faster than expected, the difference in forecasting resolution could directly translate into thousands of households failing to evacuate in time. All the while, the eyes of the scientific community remain fixed on potential solutions. Some are urging an emergency appropriation to fix the so-called cybersecurity vulnerabilities that triggered the DMSP shutdown. Others suggest that NASA and NOAA must accelerate the next generation of satellites specifically designed with advanced microwave imaging that can replicate or surpass the capabilities of the older DMSP system. Still others propose focusing on improved airplane reconnaissance, launching advanced sensors like dropsondes into the storm's interior to fill in the data gap. Yet none of these solutions can be implemented overnight. It is hard to avoid concluding that NOAA and the National Hurricane Center are at an inflection point. On one side is the desire to maintain the best possible vantage on storms venturing into American waters. On the other side are the budget watchers and cybersecurity experts insisting that older military satellite systems present too many risks. Overlapping that tension is the reality that climate variables might be fueling more frequent or more intense storms, though the science around that remains complex and is an ongoing subject of research. That said, no matter how advanced forecasting becomes, hurricanes remain unstoppable forces of nature. Even the best technology only grants us the gift of anticipation, the knowledge of where a storm will head and how strong it might become. The question is whether we, as a society, deem it worthwhile to maintain that knowledge at the highest possible resolution, or if we grow complacent. The sudden elimination of DMSP data highlights how fragile these data pipelines can be. As we come to the end of this deep dive, consider how your own community prepares for hurricane threats or even strong storms. Do you rely on timely TV broadcasts, phone alerts, or local authorities for evacuation instructions? Each of these channels ultimately traces back to the underlying forecasts that are now under threat. Keeping them robust may prevent tragedies of epic proportions in the future. Where then do we go from here? In the short term, NOAA's forecasters will do their absolute best with the resources available. But there is no doubt, losing a prime source of real-time storm imagery is a serious setback at the worst possible time of year. That spells potential trouble for coastal communities already worried about the next big storm. In the longer run, perhaps this incident will spur new collaboration among federal agencies, or even persuade decision-makers to prioritize the continuity of weather data streams above bureaucracy. Whatever happens next, it is clear that every hour of warning can matter in the face of a looming tropical system. In a world where certain storms can strengthen by leaps and bounds overnight, ignoring the data is perilous. Whether the National Oceanic and Atmospheric Administration can plug the gap in time is a drama unfolding right now, a story that could shape the fate of countless people living near the shore. Thank you for joining us on this deep exploration of the shocking disruption inside the community of hurricane forecasters. Stay safe, stay vigilant, and keep an eye on the skies, because when that swirling mass of clouds moves in, the clock starts ticking. And if you value in-depth investigations like this one, please remember to share it with others as well, so we can keep the conversation alive about safeguarding our coastlines from nature's fiercest storms.